Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I hope everyone is doing well. So in this video, I'll be showing some examples on the maximization and minimization using the Lagrange multipliers. So this is basically just a continuation from our previous discussion, where we already did one example with regard to we help a farmer on with regard to building a fence. Okay, so now let me just get the slides on. And okay, so this is basically just a review of the procedure, how we can apply the Lagrange multipliers. So our objective would be to maximize or minimize something. So in economics, most of the time we would want to maximize profit. We would like to maximize revenue. We would like to maximize productivity. And with regard to minimization, for example, we would like to minimize cost. Okay. So to do the Lagrange multipliers, there are simply three key steps. So step number one, you need to collect all the information given in the question and separate them into two. The first one would be the objective function, okay, which is either the profit function or the cost function that need to be optimized, and then the constraint function. Step number two is simply to form the Lagrange equation, okay, where you have to introduce the Lagrange multiplier lambda, okay, and remember that it should be a plus sign here, and remember to rewrite, okay, your constraint in this form, where the right hand side must be 0, okay. At this level, we're going to simply assume that everything going to be exhausted. I mean, there will be no excess. You will simply utilize all the resources up to the maximum level of the constraint. And then step number three, the last step will be to set all the partial derivative of the Lagrange equation, set them equal to 0, and then try to locate the critical points. Okay, the critical points are basically the values of x, y, and lambda that solve the system. Okay, so at this level, again, we're going to simply assume that the critical points that you found in step 3 will always produce the solutions. Okay, of course, for a higher level, this is not always the case. You are supposed to perform additional tests, but that will be outside the coverage of this course. Okay, so let's continue with this example, minimization. So let's say this is the information given, okay, where we want to minimize this function, this objective function, okay, subject to a constraint. Okay, so we have f, which is a function of two variables, x and y, subject to x plus y equals 10. So step number one. So how do we do this? So step number one would be to summarize the information, to write, okay, the problem in a proper way. Okay, I mean, this is simple enough, right? I mean, so let me just follow the slides here. So you need to write it like this: minimize f, x, and y, which is the objective function, subject to, see, from this format, arrange it into this. That's y minus 10 equals 0. So this would be the constraint. Step number two would be to collect all this, to rewrite all of this in a Lagrange equation. Okay, and how do we do that? Simple. So your slides use capital F. I would like to use this stylized L for Lagrange. Okay, x, y, and lambda. So rewrite the whole objective function. This is our objective function. Okay, and then we have plus lambda, and rewrite the constraint here. X plus y minus 10. As simple as that. Okay. And step number three, we simply take the partial derivative. So this is step number two. We just try to put it over here. So step number 3, simply to take the partial derivative, L sub x would be 2x, there is no x here, so 0, plus lambda equals 0, L sub y equals, this one becomes 0, this becomes 2y. There is a y here, so we have lambda equals 0, and then Lagrange with respect to lambda. So we're going to get the original constraint function back. Okay, so usually we're going to number this equation 1, 2, and 3. You can see here. Okay, so now after we have we have already got the information from step number 3. So L sub x was 2x plus lambda equals 0. L sub y equals 2y plus lambda equals 0. Sub lambda equals, x plus y minus 10 equals 0. So I'm going to number this equation 1, equation 2, equation 3. Okay, so now we need to find the critical point. So how do we find the critical point? So these we have 3 unknowns. We have x, y, and lambda, and we have 3 equations. So we have enough information to basically solve for the values of x, y, and lambda. We have 3 equations, we have 3 unknowns. So we can solve for x, y, and lambda in principle. Okay, so this is all of these, we set them to be equal to 0, set them to be equal to 0. This is lambda, this is lambda. So I'm going to solve, and we have x and y. So one strategy is to solve for x and y. So from equation 1, so this is the strategy that I'm going to do. Solve for x and y. So from equation 1, 2x equals negative lambda. So x equals negative lambda over 2. And from equation 2, I have 2y equals negative lambda, right? I mean, I'm bringing lambda to the other side. So my y will equals to negative lambda over 2. So now these two, this is x, this is y. So I'm going to put this x and y in the, so sub this into equation 3. So my equation 3, so now x, what is my x? So negative lambda over 2 plus, be careful with the sign. Okay, if you are not sure, always make use of bracket 2. So this is minus 10 equals 0. So I'm just going to put it here. Okay, so negative lambda plus negative lambda. So we have 2, right? Negative 2 lambda, negative 2 lambda, negative 2 lambda over 2 equals 10, right? Okay, so here then lambda, then so this is negative 2 becomes 1. So negative lambda equals 10. So now I have solved for the value of negative lambda. So in this case, lambda equals negative 10. This lambda, I can then solve for x and y, right? X and y. So what is the value of x? So x would be, now x was is given in this, right? This is x. X equals, if you're not sure, just do it. So negative lambda over 2. So negative lambda is 10, right? So I'm just going to write 10 here. But it's this is negative lambda, right? 10 over 2 equals 5. And y equals negative lambda. Negative lambda is 10 over 2 equals 5. So I have solved the critical points. Okay, so we have the critical points would be point x, y, and lambda is now given by 5, 5, and negative 10. And we're gonna, based on the assumption, this critical point would already give us the minimum, the local minimum. Okay, so let's go through the slides. And what we need to do next, we take the Now, this is an additional step 4 because sometimes in the question, we are asked to solve for what is the minimum value. So what we need to do is simply to substitute x, y back into the original objective function. So 5 square plus 5 square, 25 plus 25 equals 50. So this is the minimum. Okay, minimum what? It is not known because it's not, I mean, that information is not given. Most probably this would be cost. Okay, so this would be one example of minimization. And I'm going to stop here before we do the next example. Okay, I think it would be better to just to make the video to be shorter so that you can basically navigate easier. Okay, so that's all for now. Inshallah, I'll try to do one or two more examples. Okay, Assalamualaikum warahmatullahi wabarakatuh.